Hello, we are back in the Unit 2 notes, looking at graphs of functions. So you should be on page 5 of your notes, okay, of the Unit 2 notes. Here we have a graph showing merchandise total versus shipping and handling. This is an interesting graph because it has these sort of jumps, right? Well, let's think about what that means. What does this really mean? This is saying if you have a merchandise total between $0 and $15, your shipping and handling is $6. If you have a merchandise total between $15 and $30, you're going to pay $8 for shipping and handling, and so on. Okay? And from 30 to 45, it's 9, and whatever. It's got some weird tiers here. It's not even tiers, but that's what's happening here. Is this really a function? Well, if you have a certain merchandise total, is it possible for you to pay two different shipping and handling costs? The answer is no, right? They can't charge you two different costs for shipping and handling. It's whatever it is, right? And so this is a function. You can also see that by checking the vertical line test, right? Anywhere you draw a vertical line, you only hit the graph at one point. Where this is most interesting or something to consider would be at like 15. Notice that when the merchandise total is $15, this is an open circle down here at 6, meaning if your merchandise total is $14.99, then you pay $6 for shipping and handling. But as soon as it hits 15, you jump up because that's where your filled in circle is when your merchandise total is $15. So you jump up to $8. Okay, so let's say H here representing handling, H of 15. What is this? Well, that's saying what is the dependent variable when the independent variable is 15. When the merchandise total is 15, along the x-axis here, what is the dependent variable? It's filled in at 8, so it's $8. Okay, when you have $15 worth of merchandise, you pay $8 shipping and handling. What about H of 50? This is a similar thing. We just have to come over here. 50 is in the middle of these two, kind of about here, right? Go all the way up to where you hit the graph, which is going to be about here. That is $10 for shipping and handling there. Okay? All right, here it is asking to find x when h of x is equal to 15. That's saying this is like your y, right? So what merchandise totals will cause you to pay $15 in shipping and handling? And that we need to come up here to where shipping and handling is $15. We go over and find the correct x values here. So really, any x value between 90 and 120 would work here. We do need an equal sign on the 90 since that is a filled in circle at x equals 90. It's open at 120, so we leave a bracket there, meaning if you have $119.99 in merchandise total, you pay $15 in shipping and handling. But if you have $120, you jump up to this number. What is that? $18 in shipping and handling. Okay? So any numbers in this range would work there. So for example, H of 100 is 15. H of 92.73 is 15. $92.73 is 15, right? If It's still a function because you don't have one x going to multiple y's. You have multiple x's going to the same y. That is okay. All right, domain and range here from the graph. This is something we have not done. Domain is possible x values, right? So when I look at a graph and I want to know domain, I'm always thinking about projecting onto the x-axis. So thinking about, let me grab a different color here. Thinking about taking this point, projecting it to the x-axis, or this point here, projecting it to the x-axis. All these points kind of get squished to the x-axis, and I am covering all of this portion of the x-axis by everything below the x-axis. And if I take these top things and project them down, they project down to here. So what x values am I actually covering? I'm covering -2 to 2 using a bracket because I have a filled in circle at both of those places. So I am including those values. I do a similar thing for the range. Project all my values over to the y-axis because range is y values. So I take this point, project it over. These points down here, projected. All of these points get projected over. My lowest point here gets projected over, and that becomes my minimum of my y values. But if I projected all of these points along here over, I'd cover all of these y values. These here projected over are going to cover these, and then these here projected over are going to go up and cover all of these, right, until about here. So I'm covering all of these y values from -1, including -1, up to, what is that? Hold on, I'm going to erase a little bit of this so I can see a little bit better what that is. Let's see here. Try to go straight over there. Maybe approximately, we're going to approximate here, positive 1.3, maybe. This is an approximation when you have the graph because you don't have an equation to say, yes, it is exactly these values. Okay, so we covered that part of the y values. That's what you're looking for. What y values did you cover? And that's why I kind of like that visual of projecting all the points over to the y-axis to see exactly what I covered. Now, up here, if I were to project over, let's talk about the domain and range here. So my domain here, think about projecting down to the x-axis from 0 really to infinity in theory, right? We're kind of assuming there's an arrow on that to say once you get to $120, anything above that, your shipping is $18. Okay? But the range is a little different. I'm going to have to list some numbers. You can have $6 in shipping and handling. You can have $8. You could have $9. You can have $10. You can have $12. You could have $13. You can have $15, or you can have $18. Remember, range is possible values of the dependent variable. How much shipping and handling can you pay? Those are the possible values. How much can you buy in merchandise total? Well, obviously not negatives. That's why we're talking about 0 to infinity, as much as you wanted to spend on this, particular place. Probably a website if you're paying shipping and handling, right? Okay. This is the last topic in this sort of section. We've got more to cover for this week, but the last topic for this sort of basics of functions is intercepts. We're going to talk about what an x-intercept is and what a y-intercept is. The y-intercept is the point on a graph where it crosses the y-axis, and an x-intercept is where it will cross the x-axis. Let's talk about these for a second. We're going to fill in these notices. The y-intercept, let's come down here and look at an example. We want to know where we're crossing the y-axis. Well, that's down here at this point, right? Y-intercept is the ordered pair. X value is 0, y value is -2. The x-intercept, that's going to be this point right here. And we're kind of approximating based on a graph, right? From a graph, you can't tell exactly. It could be -1.99999. We're kind of approximating here. X-intercept is the ordered pair -60 for this particular example. Let's look at this next graph here. Y-intercept, x-intercept, we want to know. Y-intercept, where does it cross the y-axis? That's this axis. Well, that function crosses right here. That appears to be at the origin, 0, 0. X-intercepts, I seem to have a couple of them. I have one here. Oh, I have one here too, right? Because I'm talking about where I cross the x-axis. These are all x-intercepts. -2, 0. Don't forget that 0, 0. And also 2, 0. So what I wanted to do here was talk about how do you know when you have an x-intercept and a y-intercept. From the graph, we can kind of tell approximations, right? We don't know exact values, but we're guessing approximately that if we're on an integer there. But if we look at these two y-intercepts, notice the ordered pair that we found for this y-intercept and for this y-intercept. Both of them had an x-coordinate of 0. That x-coordinate is 0. This x-coordinate is 0. That will always be true. The y-intercept will always be where x is 0. Think about where you have y-intercepts along the y-axis. No matter what point you're at along a y-axis, the x-coordinate is always 0. For the x-intercept, notice our points here. All of them have a y-coordinate of 0. Because any point along the y-axis, no matter where it is, which is what you're looking for, right? Points along the function that are on the x-axis, all of those have a y value of 0. Every point along the x-axis has a y-coordinate of 0. Okay, so graphically, that's what we're looking for. We're going to talk about algebraically how to find those more later. Okay, I'm going to stop this video here because it's a nice, good stopping point. We will come back and talk about more on functions and their graphs. These are our objectives that we're going to hit next. So we'll come back and do a video on that. So take a little break and come back when you get a chance to watch the next video.